Well, today I want to talk to you about machine learning for dApps. What the hell is a dApp? Well, before I tell you that, let me first introduce myself. So my name is Diwaker. I'm the head of engineering at a company called Blockstack. Now, Blockstack is a decentralized computing network and app ecosystem that puts users in control of their identity and data. And we leverage blockchain technology to do this. Before that, I spent 4 years at Dropbox, where I oversaw all of Dropbox's efforts around search, machine learning, and AI. So naturally, I've been interested in this intersection of blockchain and AI. I should add that while I will mention a few different projects in this talk, I'm not affiliated with any of them. It's mostly my curiosity that I want to discuss with you. All right, so to understand what a dApp is, let's unpack how most apps as we know them are built today. So at a very high level, you have an identity layer that's usually your email, your social media account, or phone number. And then there's all your data, which usually stays with the service provider. And finally, there's the actual application code, which both for mobile and web apps tends to be a mix of client and server code. But the overall environment is trusted. We trust companies with our identity. We trust that they will keep our data safe. We trust that app stores won't contain malicious apps and all apps will be treated fairly and equally. Of course, that's not always true. Now contrast that with a dApp. So a dApp is essentially a decentralized application. Quick footnote here, that while I'm talking about dApps in the context of Blockstack, most of these ideas generalize to other platforms as well. So in a decentralized application, the identity is managed on the blockchain. So the identity is owned by the user and free from control by any other entity. Storage is federated, meaning that users can choose where their data goes, and the data is always encrypted and under the user's control. So each application gets its own secure vault with mechanisms for secure data sharing between applications. Rich access controls govern data access and that users can revoke at any time, and most of the code is running on the client side. So in this model, users need not trust any one company or the app developer. And this is not some fringe movement. There are real developers trying to build applications that provide value to real users. In just 1 year, we've seen hundreds of applications and thousands of engaged community members, and that's just on Blockstack. There are dozens of projects trying to build their own decentralized ecosystems. So what does all this have to do with machine learning? Well, I don't need to tell this room the impact machine learning has had on our industry, on our society. The bottom line is, as users, we expect that our products will get better over time, that they will learn from our interactions with them. And machine learning has proved very effective at doing that for a broad range of use cases. Now, in a resource-abundant environment, we know how this typically works. Machine learning, especially deep learning, needs a lot of data. Often that data is generated by the users themselves, which allows companies to create these big data moats. Again, like large companies have a lot of ML expertise and resources to throw at some of these problems. But I'm sure many of us in this room will recognize that the playing field is not level. Companies that have more data and more resources tend to have an advantage. Now think about dApps. Most apps today are created by small teams with very limited expertise and resources. And then when users control their own data in a privacy-conscious ecosystem, it becomes much harder to indiscriminately collect large data sets. So it is in this context that I want to talk about how blockchains could offer some solutions for truly democratizing machine learning. Now blockchains come in all shapes and sizes, and rather than try to use some canonical definition of a blockchain, let's just focus on 3 key properties that most blockchains provide. So first, blockchains provide an immutable log, which makes them great for transparency because you get a verifiable audit trail that anyone can independently verify. Second, blockchains let multiple parties coordinate without trusting each other. And so you get to interact with different entities in a trustless, permissionless manner. This is great for marketplaces because more entities can now participate and expect a fair outcome. And then finally, with tokens and smart contracts, which is basically programmable money, blockchains are great at codifying incentives. So you can really create incentive alignment and codify it in a way that the system automatically enforces it. All right, So how can blockchains actually help democratize ML and bring machine learning to dApps? Let's start with an easy scenario. Say you're building a photo gallery dApp and want to let users search through their photos. Thankfully, for this domain, there are readily available datasets, many pre-trained models, and dozens of commercial APIs you can use. Easy, right? Well, setting aside the cost of using some of these commercial APIs, especially at scale, I personally have been bitten by third-party vendors silently changing their models underneath that impact the product behavior. And this lack of transparency actually extends to the datasets themselves. So, quick show of hands, who here has used ImageNet? Either the raw datasets or the pre-trained models? Okay, just a handful, smaller than I expected, but still. So researchers at the AI Now Institute published a fascinating report that looks into the public image dataset, especially ImageNet. So here's an image with a label that clearly doesn't make sense. Now there are countless other examples of labels that range from funny and bizarre to dark and outright disturbing. So one potential solution here is to develop models in the open with full transparency, and blockchains provide a good platform to do that. So Microsoft Research recently launched a prototype system running on top of the Ethereum blockchain that does exactly this. So in this model, participants can collaboratively and continually improve and maintain models as well as contribute to public datasets, all happening on this public blockchain. So the basic idea is that users are incentivized to add data that improves the model. All data and metadata gets stored on the blockchain, which ensures that it remains available for future use cases. So when you first add or try to add new data, it goes through 3 steps. All these steps are codified as smart contracts on the platform. So first, an incentive mechanism gets triggered that checks whether the data actually improves the model. And this way the network can penalize bad actors and reduce bad or noisy data. Next, there's a data handler that persists that metadata and the actual data on the blockchain. And then finally, you update the model. In their model, the authors, the way they've constructed it, the model is free for everyone to run queries against, and you can even pull the model down locally for inference. Now keep in mind that smart contracts are also immutable, and they are run or validated by many different machines in the network. And so this kind of redundancy helps ensure that the model actually behaves according to its specifications, and that the awards are reliably computed and fairly distributed for good data contributions. Now obviously this is not without limitations, and the paper goes into a lot of details on exactly which kind of models can be constructed today, but it's still an interesting approach. But the biggest problem here is that the many datasets and models are simply too large to be stored on blockchains. Blockchains are not that good at this kind of use case where you want to store a lot of data on them. And further, this assumes that you already have some baseline model and some dataset that you're working with, that you keep adding to and you keep improving. But what if you don't have that? So let's say you want to build a personal wealth manager dApp that offers ML-driven insights into your spending and investments. So here you have a cold start problem. You have no existing data to train on or models that you can use. So how can we train models on private user data or incentivize fair, transparent, responsible data collection? There's one more problem. If you do have some raw data, how do you go about labeling it? And one common approach that practitioners in the industry use is to kind of farm out these labeling tasks to platforms like Amazon's Mechanical Turk. So again, another quick show of hands, who has used Amazon Mechanical Turk for this kind of a training or labeling job? Okay, just a few more hands here. So if you don't know what Amazon Mechanical Turk is, it basically allows you to create these tasks that typically end up being very low-cost tasks, and that you farm out onto the platform, and workers from all over the world can pick up these tasks and do the labeling for you. And typically relying on these third-party contractors can lead to some transparency and fairness issues, and the image example that I showed you earlier was just one instance of that. So luckily for us, blockchains are great at codifying incentives via smart tokens and smart contracts. So let's take a look at a few examples. So as I was just saying, one way to get out of the cold start problem is to incentivize the collection of data via a marketplace. There are many projects that are trying to tackle these kind of problems. A relatively new one is called Computable. So in their model, different entities and their interactions are governed by a series of smart contracts. So on the top left, we have what they call a patron. So this could be either the app developer or someone else, a foundation, a nonprofit, that wants some data set to exist so they can add some capital into the market to bootstrap that process. On the supply side, makers can submit new data listings that stakeholders in the network can vote on. And then if their listing gets approved and is contributed to the data set, they get a share of the data transactions. So when the maker submitted a listing, they send the actual data to this entity called a data trust. This is an off-chain entity, so this could be any normal storage company that's providing this as a service, and they also have an incentive structure for all the data sets that they store and serve, they get a fraction of the transactions as well. So the data trust verifies the data and sends a hash of the data back to the market, confirming the receipt and linking the on-chain state to the off-chain data store. On the demand side, buyers go through a similar process where they make a payment to the market sends a proof to the data trust to validate whether the data set kind of qualifies for the request. Once the data trust confirms the payment, it delivers the data to the buyer. And in this process, the listing owner receives an appropriate share of the payout as well. So again, all of this is mediated through smart contracts, and the incentives are really aligned around how useful data is. So the more use a data set gets, the more money it generates, essentially, the more value it creates on the network. Okay, so this is potentially interesting to incentivize data collection. Can we extend this model of a marketplace to algorithms and services as well? So one of the bigger projects in this space is called Ocean Protocol. This is also based on top of the Ethereum blockchain. So what Ocean tries to do, again using smart contracts, is to facilitate a rich ecosystem of both data and services. And Ocean also has this notion of bringing compute to the data. So a provider of algorithms or models essentially delivers a packaged model that gets shipped off to where the data resides. So on the consumer side, a customer can run that model on-premise, and then there's some output of the model that presumably makes it hard to identify what the data set was, and you send that output back to some aggregated layer. So this figure shows sort of a layered view of Ocean's architecture. At the top, we have the end user. In their case, happens to be a data scientist. There's a layer of curators that help bubble up the most popular services and data sets. Next, there is a network of verifiers that enforce access control, so whether a particular algorithm or model has access to a given data set. And underneath that, there's a network of what they call keeper nodes. These are the nodes that are running the actual blockchain components that execute the smart contracts and are responsible for managing the accounts and the rewards. And then finally, we have the actual data and service providers. So in their case, service providers would even be public cloud providers or other entities. So you can actually check out a hosted Jupyter instance at this URL. I think Trent, who is one of the co-founders of the project, was here last year talking about this. So it's a really good way to just play around with how all of this comes together in an actual usable fashion. There is also a data commons marketplace that they've created that again you can check out to see how the marketplace actually functions in practice. And if you would like to participate in Ocean, now's a great time because they recently announced a data economy challenge. They've also lined up an impressive array of corporate and government partners, especially in Asia. So I'm pretty optimistic that this project will get some traction and help us create some of these more open and fair marketplaces. But let's face it, these systems are all very early, and there is still a lot of inertia and friction to overcome. But the onus is on us as a community to level the playing field and demand more transparency. So next time, if you're in need of a data set, or if you want to farm out some jobs to Mechanical Turk, or if you're looking to get some expertise, ask yourself if you can use one of these marketplaces instead. And so that's become kind of full circle. I started with the notion of a DApp, a decentralized application, that leverages blockchain and other technologies to put users in control of their identity and data. And we looked at some challenges imposed by this constrained environment where data and compute is localized at the edge, and which makes it harder than with normal centralized applications to incorporate machine learning. And we saw how blockchains can potentially help alleviate some of those pain points by facilitating trustless, fair, transparent marketplaces of data, services, and algorithms. That's it for me. Thank you, and I'm happy to take some questions now, if we have time.
Thank you so much. We have some roving mics in the room, so if anyone has a question, please do raise your hand and we'll come to you. Do we have any questions?
It's really interesting to see how blockchain technology is really working alongside with machine learning. It might be a new concept for our audience this time around. Why should our audience of executives and leaders be considering blockchain as part of the solution?
So there are a few things. I think a few years ago, when AI was sort of going through this hype phase, and blockchains were also going through this hype phase, there was this meme that you put these buzzwords together, and something will come about. But I think over the past few years, we've kind of seen the technology evolve to a point where there are actual legitimate use cases where it makes sense. So from my perspective, blockchains offer, as I said, a few very interesting properties that are useful in any environment where you need to coordinate with entities without trusting them necessarily, where you want a fair and transparent mechanism that allows you to kind of audit things. Like even in an enterprise environment where, let's say it's a permission environment, you can still have a blockchain that allows you to sort of keep an audit trail of all changes that are happening to, let's say, a machine learning model. I'm not saying that that's necessarily the best way to do it, but it does create that, it's one more option on the table. So I would encourage people to kind of look at it and see if it meets their use cases.
And would you say that this is a way to bring people together across sectors and industry to bring data sets together?
Absolutely, absolutely, yeah, 100%.
Fantastic. I'm going to ask the audience if there are any questions at all. Okay, please do join me in thanking Diwaker.
Oh, I think there's one question in the back there.
Hello?
Hello.
I can hear you.
Okay, we have a question at the back. If we could get a mic to the kind gentleman, please. Fabulous. Go for it.
It does? Doesn't work now. Okay, fantastic. Thanks for the presentation. You brought up the data mode, and we've got...
You know what? And let me just come down there, and I'll come find you.
Okay, well... Hard to hear me now?
Yes, we can get you now.
What I understood the presentation to be...
I'm sorry, I think you keep breaking up. Let me just come down to you.
Okay, well, I'm here anyway.
All right.
So essentially, it's a competition between distributed computers, right? So
Our audience might be able to hear you.
We might be able to hear me now? Okay.
Yeah.
So the competition between distributed and the modes, and the modes have the power. So how do you get the power to the distributed ecosystem?
Yeah.
How feasible is that actually?
Yeah, well, feasibility, I think it's a question of whether we have the courage and the willingness to actually do something about it. I think we have the tools at our disposal. A good example is medical records. A lot of healthcare improvements are kind of bottlenecked by the availability of good medical data, and in many cases it's siloed off in clinics and medical centers, and often as patients don't even have access to their own data sets. So in a hypothetical world, if all of us had control over where our medical records were, and we were able to give our consent or allow data to be shared in a way that's not violating our privacy, and pool that, and then make it available for drug discovery, again in a way that the incentive structure is set up so that the utility gets rewarded, then I think that's one way we can make progress here. So there are certainly, I think, good problems to be solved here, and it just requires the willingness